from this computer. Share the screen. Microsoft Whiteboard, it should be sharing. So if all versions of the test had the same, yes, be careful. All the versions of the test had the same first question. What are the allowable values for probabilities? Well, a probability, you write it like this, must be between 1 but greater than 0. That's it. Now, some of you explain it in words, but I was like, why can't you write that? Why can't you write that? So for this one, it would have been the same answer. Se pasó. Wait, give me a second. You know, I'm pretty sure, and I don't know why it keeps on doing that. Let me see if I can just get the mouse and unclick it. There we go. So they all had the same answer. So let me do that. Now, the next question, depending on which version you had, I'm going to go through each one of the versions. The next question for number 2 said, could you please draw a tree diagram for the probability experiment consisting of flipping a coin and then rolling a 6-sided die? This is an example I did in class. Okay. Oh no. Same exact one. I wish I could lock these things in place so they don't move. So in this case, zoom in a little bit more. When you flip the coin, you could either get heads or tails. And when you roll the die, you get a 1, a 2, a 3, a 4, a 5, or a 6. And when you did it for the other one, if you had gotten a tail, you get a 1, a 2, a 3, a 4, a 5, or a 6. There's 12 possible ways. Now, for version B, I asked you, could you please draw a tree diagram for the probability experiment consisting of flipping a coin 3 times in a row? Well, that was just heads or tails. And then you had heads or tail again. And then you had heads or tail again. I did this in class as well. So it could be heads, 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 tails, head, tail, heads, head, tail, tails, tail, heads, heads, tail, heads, tails, tail, tail, heads, tail, tail, tail. Okay. Now, for version C, it was the same question, but this time it was 4 rolls, four flips, sorry. So when you did that, and the tablet obviously is misreading my palm right now. And for some reason, my forearm is sore as I'm writing. I don't know why. This tablet is acting up. So you have that. And we'll go ahead and not make this tail this so wide, but make it wider this way. So that's 2, 3, right? And then you will do it one more time. Now, of course, I'm running out of space there. But even running out of space, I can clearly show what my tree diagram is about. And there should be 16 different outcomes. Namely H, 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 T, H, H, T, H, 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 T, T, you get it. So far, so good. So now let's go ahead and go to number 3 on the version A. And I think I did it I just, you know, you got to remember what a simple event is. So I think I made it very similar to all of them. Is the following situation a simple event or not a simple event? A simple event is an event that only has one outcome. So here it says event A is selecting a king. Well, you can get a king of hearts, you can get a king of spades, you get a king of diamonds, you get a king of clubs. That's 4 different events. Not simple. I mean, you see what I'm saying? Like, it's super easy. When you look at the next one over here for the next version, it says event A selecting a heart. Well, there's 13 hearts, right? You got a 2 of hearts, a 3 of hearts. That's not a heart. All the way to 10 of hearts. Then you have a J of hearts. Then you have a Q of hearts. And then you have a king of hearts and an ace of hearts. That's 13 different events. This is not simple. Not simple. The next one says event selecting a red card. Well, half of the cards are red. Half of the cards are red. That's 26. There are 26 possible outcomes for that event. This would be not simple. So all 3 versions, I just thought that that was self-evident. And so many people just kept on saying simple, 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 simple. Now, question number 4 was the hardest for each of these. But I think after I review them, you're going to be like, oh, that wasn't too bad. So for the first one there, for version A, it says, please use the counting principle to determine how many ways the following situation. The access code for a car security system consists of 4 digits. The first digit can be 0, 1, or 2. The last digit must be even. The middle 2 digits has no restrictions. How many different codes are available? Well, the first one has 3 ways. The second one has 10 ways. The third one has 10 ways, right? Because there's no restrictions. You can pick for the first one 0, 1, and 2. For the middle 2, you have no restrictions. You can pick 0 through 9. Those are 10 numbers. And the last one, you can pick even, which even are 0, 2, 4, 6, and 8. Those are 5 numbers. 0 is even. Right? We don't think that way. We omit it because we know 2, 4, 6, 8, 10 are even. No, the digits is 0, 0 is even. Make sense? Yeah. If you divide 0 by 2, do you have a remainder? So that's even. 5 divided by 2, do you have a remainder? Okay. It's a remainder of 1, right? That's why 5 is odd. Make sense? So here comes out to 10 times 10 is 100, times 3 is 300, times 5, 1500. There was 1500 possibilities. So maybe that was the easiest of the versions. Let's go ahead and look at the next version. And it depends on which version you had. So for the next version, it says, okay, the first digit can be 0, 1, or 2. So we're going to multiply 3, right? And then the next, the last digit must be even. So that's 5. So over here somewhere it's 5. And then the middle 2 digits can only be 1, 2, 3, 4, 5, 6 numbers. So 2, 3, 4, 5, 6, or 7, that's 6 numbers. So it's 3 times 6 times 6 times 5, because there's 4 digits. Right? So that's you carry out that multiplication with the counting principle. And that will quickly allow you to ascertain that's 540. Now, Gabriel in the middle of the test was trying to make a tree diagram for this. 540 different ways. It doesn't make sense to do that. Okay. So now we do the last version. Okay. So in the last version, It says the first letter can only be capital. So for the first digit, you have the letters. So there's 26 letters. The last digit must be even, that's 5. And then 2, 3, 4, 5, 6, or 7, there's 6. So it's 27. So the middle two have to be 6. The middle two are either going to be 2, 3, 4, 5, 6, or 7, right? And the last one's even. So it's like that's what you do. You multiply that out. And you didn't have a calculator. I just said just write down what you would multiply. So it's 26 times 6 times 6 times 5. So that's 4,680. Those are 4,680 different codes you can have. All right, so now let's go ahead and do the next 3 for version A, and then we'll do the next 3 for version B, and next 3 for version C. And then I think basically I'm able to answer 9 and 10 depending on the circumstance. So what is the probability of rolling greater than 4 when you roll a 6-sided die? So the probability of rolling greater than 4 is, well, it's 5 and 6, so that's 2 out of 6 total. 1/3. 0.333. Whichever one I would accept.
Yeah, it's not showing.
Oh, it's not showing it. So I'm in the wrong version, just didn't come out now.
Yeah.
Okay, so let's.
No other.
Oh, I'm doing, which version am I on right now?
You have to go right.
I'm on version C. Coño. Okay. It doesn't matter. I'll go, it doesn't matter, whichever way it works. All right, so there we go. And it says, what are the odds of drawing reds from a standard deck of cards? So how many reds do we have in a standard deck of cards? 26. Okay. What's left over? That's the difference between probability and odds. This is a 1-to-1. This is a 1-to-1 ratio. If the probability of events A is 5 divided by 17, 5 over 17, what are the odds of event A? Well, odds of A, how many ways can I get event A? How many ways are left over? That's it. That's how you do odds. If you take 5 plus 12, you get 17, which is the denominator of the probability. You can't reduce that, so you see it like that. Now, the next one says, explain why you can't have a 150% chance of rain. You would say something like, the maximum allowable probability of any event is 100%. The minimum is 0%. 150% is not appropriate to say, something like that. Super simple. But some people said it's like only 100% or something like that. They messed up their answer. They destroyed their answer. Some people didn't know what they were talking about. So you would say something like that. All right. Now, just quickly, what type of probability is the following? According to companies' past records, the probability that an employee will quit on any given week is 5%. That's empirical. Now, it's so funny that people misspelled empirical. Some people spelled imperium. Some people said statistical. Empirical probability is the correct thing. Now, the last one in this version C, it says explain classical probability in your own words. I mean, some people said flip of a coin, but if you said only the flip of a coin, it wasn't no good. Now, some people said flip of coin, roll a die, lottery, and I kind of gave you credit. But what I wanted to see is, I want you to say, what word did we use for the set of experiments where, and you can write probability experiments, set of experiments, or let me make it easier. a probability experiment where each outcome is equally likely, has an equal chance, equally likely. And that's what makes something classical. Example, flipping a coin. Rolling a die. Picking a card. Or a lottery. Okay. Now, version B, if you had version B, what is the probability of rolling greater than 5 when you roll 6-sided die? Well, the probability of rolling greater than 5, that's just 1 out of 6. 1 divided by 6. There's one possible way of getting bigger than a 5. Since all the probabilities are equal likely, we just write 1 out of 6. What are the odds of drawing a spades from a standard deck of cards? Well, there are 13 spades. So the odds of spades is 13 to what's left over? What's left over is 39. See, the probability of spades will be 13 divided by 52, but the odds of spades will be 13 to 39. How many ways I can get my spades? How many ways I cannot get spades? And this reduces to 1 to 3. And that's the difference between probability and odds. If the probability of event A is 5 divided by 7, then they're asking here for the odds. So the odds of A, well, how many ways can I get A? 5. How many are left over? 2. 5 ways to get A's, 2 ways to not get A. 5 plus 2 is indeed 7. Like in the previous problem, 13 plus 39. Yes.
Could you please send Janko Cruz to the main office for early dismissal, please? Janko Cruz?
I don't know. I don't know if I have that student. Oh, that's
Oh, no, I'm so sorry about that. Actually, the father accidentally put the, yes, it's Erica. Cruz, please. I'm sorry
Okay.
about that.
Okay, no problem.
Thank you very much.
All right. That's I'm like, I don't think I have that person. Well, have a Merry Christmas and a Happy New Year. Take care. Studying is good for you. All right, explain why you can't have a 150% chance rate. Again, the maximum amount of percent of probability is 100%. 0 is the minimum. Okay. What type of probability is the following situation? It's the same as the other version. This was empirical indeed. Empirical probability. Now, in your own words, explain empirical probability. I saw a range of explanations. Some people, some of the one that I kind of liked a lot that nobody answered, but some people were kind of answering it, I guess, from the definition from the PowerPoint, was in regards to saying, you know, if you have the way we do empirical probability is we have a survey or something, and we take the frequency we're interested in and divide by a total, right? That's what empirical probability is. Some people said, based on past records, we deduce our probabilities from there, something like that. All right. So let's go with that. Let's go with okay, it's a probability based on actual numbers that have been recorded or on previous numbers that we've recorded. Okay, that's what we want. So I won't even write that there. It's not necessary. But that's it. That's what it is. You can look at the PowerPoint and you'll see the definition of the book gives. The definition of the book will use the F divided by N formula. Now this one, what's the probability of rolling an even? So this is version A. The probability of even is just 3 divided by 6, which is half. There's 3 numbers that are even from 1 to 6 when you roll that die. So that's 0.5. What are the odds of drawing a queen from a standard deck of cards? So the odds of queen, well, how many queens do we have? 4. How many cards are left over? 48, and you're done. You can reduce that to 1 to 12. Some people were reducing that from 1 to 13 because they were thinking 4 divided by 52, which is not, that's not what it is. The odds of A is 4 to 3. And again, same explanation for number 8. You can't have more than 100. Something like that. A little bit more. I want to see a little bit more, but whatever, something like that. And then number 9 is the same as the other version. This is empirical. Definitely it's empirical. And then it says, explain classical probability in your own words. And like I said previously, classical probabilities has to do with probability experiments where all the outcomes have an equal chance of occurring. Make sense? So if I had to, let me go ahead and copy and paste that over here. I think I can copy it and paste it. No, it didn't work, bro. Of course not, because it would be awesome if it works. And there we go, it worked. Something like that. I attached it there. I should put a probability experiment. All right, so it didn't even take me that long to do all 3 sections. Was that difficult? Now that I did it on the board? You need to know these basic concepts so we can proceed with probability. So aside from that, maybe I should write something there for empirical, but I'm done. And ending.